All right, today we're going to look at 6.3, which is looking at medians and altitudes within a triangle, and then how that correlates to centroids and orthocenters. First thing we're going to talk about is a median of a triangle is a segment from the vertex to the midpoint of the opposite side. So when we draw a median, it has to start at a vertex. So in this first case, we have it starting at A. It goes to the opposite side, and it creates two congruent segments because it goes to the midpoint. And there are three medians because it could start at a different vertex, go to the midpoint, create congruent segments. So there are three medians. It goes from one vertex to the midpoint of the opposite side. The median of a triangle is a segment going from the to the midpoint of the opposite side. But then when three medians of a triangle are concurrent, so they all intersect at that point of concurrency, that is called the centroid. So in this particular case here, we have P is the centroid of the triangle. And then something unique always happens, that first distance is 2/3 of the way, and that second distance is 1/3 of the way. And so that's going to be really important if you need to pause that and get that down. So in this triangle RST, where Q is that centroid, and VQ is 5, and this is going to, because it starts at R, that means that this is 1/3 of the distance. That means that this needs to be 2/3 of that distance, which means the whole distance, if 5 is 1/3 of it, RV is going to be 15, which means that RQ is going to be 10. So we can do the same thing if we have it with some algebra. So let's first mark up AP as x squared minus 2, and PD is 2x minus 3. Because AP is 2/3 of that distance and PD is 1/3 of that distance, then I can set AP equal to 2 times of PD, because PD is only 1/3. So if I multiply it by 2, it would be the same distance, and then I can solve this equation. Get everything to one side. And this is a perfect square, so I'm going to get x equals 2. And then I can plug that back in, and I can find out that AP is equal to 2 and PD equals 1. Make sure, in this case, it's set to solve for x, but make sure that we are always solving for what it is asking for. In order to find the coordinates of the median, first off, we need to graph this. So 0, 4, -4, -2. And 7, 6, 7, 1 is C. So when I have my triangle here, find the coordinates of the centroid. So in order to do this, I would need to do a couple different things. Draw the median. So then I need the midpoint of AC. And then I would need to write the equation of the line from B to the midpoint of AC. And then I would need to do that again for a different one. And let's say C to this midpoint. And then I need to find out where that median is. Now, I'm sorry, where that centroid is. Another thing that you can do, the centroid is always the average of the 3 coordinates. So, in this case, my x values are, if you remember this shortcut, 0, -4, and 7. When I add that up, I get 3. 3 divided by 3. And then when I do my y values, I'm going to get 4 minus 2 is 2. 2 plus 1 is 3. So I'm going to get 3 divided by 3, which means my centroid is going to be at 1, 1. So it is a shortcut to find the centroid. So here, applying the fact that BD is the median, so B goes to D and is the median, that means that it creates 2 congruent segments there. So get everything to one side. When I factor, I'm going to get x equals -5 and x equals +4. I know that when I plug -5 in, it won't work. So my answer is just x equals 4, but it wants me to find the perimeter. So I need to plug 4 in everywhere. And then I'm going to get 21, 40, 32, and 32, which means the perimeter of the triangle is 125.